Good day, grade 11 and 12s. Today's video, I'm going to focus on the electrostatics from grade 11 and grade 12. This will be a reminder for grade 12, for revision for grade 12, and also grade 11 are writing electrostatics on the exam on electrostatics. Guys at home, please don't forget to watch my videos till the end, subscribe and share with your friends. Watch my video till the end. Like, comment, subscribe, and do everything that is right. Thank you so much, guys. Let's cut the chase. In this video, I'm going to look at the electrostatics, but starting from the basic level, and then I'll build up. I'll do more videos up until the complex electrostatics question. Right now, let's cut the chase. It says two metal sphere P and T are on an insulated stand, carrying charges positive 3 times 10 to the power 9 coulombs and negative 6 to the power 9 respectively, as it's written there. They are on insulated stands. Right, the sphere allowed to touch each other and then place 1.5 meters apart as shown below. So we know, guys, when the sphere they touch one another, there will be a transfer of electrons there. So there will be a transfer of electrons. This one is negative, this one is positive. There will be a transfer of electrons, guys, from the excess to the lack. This one is an excess, it has more electrons, and this one it has a lack of electrons. So always the electrons will be transferred from excess to lack, and then up until they become new charges. Now after they separated, they have two new charge. There are new charges now which we have to calculate all the time, guys. When they get in contact, they become new charges. Right now in 8.1 it says, in which direction will electron flow while the sphere P and T are in contact? Write down P to T or from T to P. They flow from T to P. So the answer here is T to P. This is the correct answer. They come from the axis to lack. Right now 8.2 it says, calculate the net charge gained or lost on the sphere. Now when they say net charge gained or lost on the sphere, we have to calculate the charge that are transferred from here to here, which means the group of electrons that are transferred from there to there. So before that, we have to calculate the new charge. In 8.2, in order to do that, we have to calculate the new charge. It says Q new is equal to Q1 plus Q2 over 2, which is going to be Q1 is 3 times 10 to the power negative 9 plus positive 6 times 10 to the power negative 9, and then we divide by 2, and then the answer there, it will be negative 1.5 times 10 to the power negative 9 coulombs. It means now the new charges here, it will be negative. Now they are negative both. It's very important, they're both negative there. Alright, okay, that's the new charge. Now we're going to calculate the charge transfer. It says new charge minus the original charge, which is the new charge. It's negative 1.5 times 10 to the power negative 9 minus the original. You can take any let's say we take the negative 6, the negative 6 times 10 to the power negative 9. So the answer there, it will be 4.5, positive 4.5 times 10 to the power negative 9 coulomb, if you punch that in the calculator. So now the next question, we are done. These are the charges that are transferred. Alternatively here, guys, you can use the other charge. You say 1.5 times 10 to the power negative 9 minus, it was 3 the original charge, so it's going to be negative 4.5. So the answer will be the same. The other will be negative and the other will be positive, right? Now in 8.3, it says calculate the number of electrons that are transferred during the process. In 8.2, guys, all the time when they want to charge transfer, the electron transfer, just like 8.3, you have to know the charges that are transferred. So these are the charges that are transferred, right? Right, now we're going to use now the quantization of charge. Quantization of charge, it says number of electrons is equal to charge divided by the elementary charge. So we'll take the positive one. So we'll 4.5 times 10 to the power negative 9 divide by the elementary charge, which is 1.6 times 10 to the power negative 19. So the answer, it will be 2.81 times 10 to the power 10 electrons. Guys, if you here, what gives you an assurance that your answer is right? It needs to be positive here and be positive there. These are the electrons that are transferred there. Let's go to 8.4. 8.4, it says a third sphere R carrying a charge which is negatively charged is now placed between P and T at a distance of what? 1 meter from T. So I'd like to draw that so that we can see. So this is P, and this is what? A T. Remember guys, they're both negative. They are new now. They are new. And then we have what? Charge R now. It's not charge R, it's charge R. This is P, guys, it's not R. This is P. This is P, and then we have charge R, which is negative. It's negative. It plays 1 meter from T. So this is going to be 1 meter. The distance, it's 1 meter, and then the distance between these ones, it's what? It's 1.5. 1.5 what? Meter. There. So since they are all negative, guys, now this is charge R, it's placed 1 meter there. Now the question, it says now calculate the net force experienced by a sphere R as a result of interaction with P and T. Guys, it's very important. T is exerting a force on this one, and P is exerting a force on this one. Guys, I hope you still remember why they are both negative. They are new charges now, which we calculated from the first calculation. So now guys, if you can draw a free body diagram showing all the forces that are acting on R, a T is repelling R because they are both negative, so is repelling with a force that is going to the left. So this is the force of what? Of T on R. And then if you look at the distance between T and R, it's 1 meter, and the distance here, it's going to be 0.5. Why is it 0.5? Because the whole distance here, it's what? It's 1.5, and then we are told R and T are 1 meter apart. So this force between these two is going to be longer or bigger. So the force of P on R, it's going to the right. It's repelling. This one is going to repel this one in this direction. So it's going to be bigger than that. So this is the force of what? This is the force of P on T. No, P on R. This is the force of P on R. Now they want us to calculate the net force in this. The net force in this. If you can draw even the vector diagram of this, guys. If we start with the force of what? The force of the force of T on R, and we draw the force of P on R, it's going to be bigger. We draw it like that. This is the force of P on R, and then the resultant there, it's going to start from the tail of the first vector to the head of the last vector. It goes there. the resultant, which is the net force there. So this is what we're going to calculate. So now I'm going to first calculate the force. The force of what? Of T on R. The force of T on R is, we write the formula there. The formula will be KQ1 times Q2 over R squared, and then we substitute the force of T on R. We have K, which is 9 10 to the power 9, and then let's say that's T. It's going to be 3 times 10 to the power negative 9, and then R, it's going to be 1.5 times 10 to the power negative 9. Remember, R is negative. Not R, T is negative, but we put it as positive in this. So the distance between T and R, it's 1 meter. So it's going to be 1 there. So it's going to be 1 square. So if we put that in the calculator, it's going to be 4,05 times 10 to the power negative 8 newtons. And we already decided the direction. The force of T on R is going to the left, or we can say okay, now let's calculate the force of what? Of P on R. Now I'm not going to write the formula since I wrote it before, so we put the K there, and I put R there, and then I put P. Now P is also 1, yeah, it's the same, but the difference now, it's going to be the distance. Now it's 0.5 square. The distance here is 0.5. So if you put that in the calculator, it's going to be 162 times 10 to the power negative 7 newtons. And we already decided the direction is going to be to the right. Now the net, you adding, since they are linear, guys, here they are linear charges like this, we just add when we wanted the resultant. So we'll have an F net is equal to force of P on R plus the force of what? Of T on R. So the force of P on R, it's 1.62 times 10 to the power negative 7 plus the force of T on R, it's negative because it's going to the left, 4.05 times 10 to the power negative 8. And then your answer, when you punch that in the calculator, you will have 1.22 times 10 to the power negative 7, and the answer is positive. It's to the right. Guys, that's the end of the question. I hope that makes sense. Cheers, bye.